Hey y'all, we are starting our next unit. It is a unit on logarithms. Today is kind of labeled as day 0. If you look up the notes in Canvas, you're going to get some notes that look like this. You have the choice to print those or not to print those. As a matter of fact, I'm going to write on blank paper just to show you that that can be done. The first thing we need to do before we start our unit on logarithms is to refresh our memory on exponents. So let's do that together. So if you look at x to the 5th times x to the 2nd, the answer is what? X to the 7th, because we know when you're multiplying, if bases are the same, you add exponents. Well, let's see, I'll switch colors, right? So number 2, 3 to the 4th times 3 to the 6th. The bases match, so the base stays the same, and that's 3 to the 10th. Number 3, x to the 7th over x cubed. The rule right here is subtraction, so that's going to be x to the 4th, because we say 7 minus 3. Hopefully this is all coming back to you and it's not too bad. So you try number 4, 5 to the 8th over 5 to the 6th. The first thing you're going to do is ask yourself if the bases match. If the bases match, then you're good to go, right? So this is going to be 5 squared, right? Now, 3 to the 10th is going to be a huge number, so we're not going to write that out. But if you get one that's nice and small, like 5 squared, it's okay to then say that that is 25, okay? 9 to the 1/2. I want to make sure you understand that the 1/2 power means a square root. So that is the square root of 9, which of course is 3. Number 6, 2 to the 1/3. That means the cube root of 2, right? This right here is the root, and that's the power. We don't know the cube root of 2, so we're just going to leave that alone. That's some decimal. 3 to the -1. I want to make sure you know that a negative exponent does not in any way mean a negative number. It means you're in the wrong place. If you're in the numerator, you should go down to the denominator. If you're in the denominator, you come up to the numerator. So that really means 1 over 3 to the 1st, which is 1/3. All right. 8 to the 2/3 means the cube root, because there's a 3 over 8 squared. Now the cube root of 8 is 2, right? And that squared is still there, so 4 is our answer, because 2 squared is 4. I guess I don't need the different colors because I'm only getting 2 per line. I was trying to squeeze more, but you guys know I write big. Number 9. Right? So the 3 and the 5 don't have exponents attached to them, so we could say 3 times 5 is 15. This and this have exponents, but it's the same base, so I simply add those up. 10, 3x to the -2 times 5x cubed. That's really 3 over x squared times 5x cubed. So 2 of these x's will cancel with those 3, so there's only 1 left up there. So 5 times 3 is 15x. 4 to the -1/2 simply means 1 over 4 to the 1/2, which is 1 over the square root of 4, which is, of course, the square root of 4 is 2, so it's 1/2. Look at number 12. And again, these are prerequisites. You know, after we do this, a good idea for you would be to pull it up online and try to do it again yourself, because these are basics. All right, so here we're going to say, you can kind of think of that as a 1. So when we're raised to a power, we multiply by the exponent. So 1 times 4 is 4, so that's 2 to the 4th, right? X to the 3 times 4 is 12. Y, negative 2 times 4 is negative 8. So that means 2 to the 4th, x to the 12th, over y to the 8th. This goes down because it's a negative. And of course, 2 to the 4th we can fix. It's not too big. It's reasonable to do that with just your mind. So that's going to be 16 x to the 12th over y to the 8th. So if you notice, this has a 4. This does not have a number. If there's no number, it's an understood square root. So that's really 2 times 4 is 8. That's really the 8th root of x, or x to the 1/8. Now there's nothing you could do with that because you don't know what x is. 14, 16 to the 3/4. Okay, that means the 4th root of 16 cubed, the 4th root of 16 would be 2, right? Because 2 to the 4th is 16, so that's really 2 cubed, which is 8. 15, 4x to the negative 2 means 4 over x squared. That negative tells you to go to the bottom. And last but not least, number 16, negative 2x to the negative 2 over 3x to the 4th. So these x's are going to come down and join those. So we really have negative 2 over 3. There's already x to the 4th. We're bringing 2 more, so that's x to the 6th. So there's a little review on exponents. We need that to go with our unit here. And one of the other things we want to look at real quick, if you can look at your notes online, you definitely don't have to take a copy, is looking at the basic of a log. When we look at the shape of a log or the shape of an exponential, let's review that real quick. We won't do too much, right? You can look this up on your notes. Pull the notes page up, but you can write on paper. I don't want you to have to print a lot of stuff. So we've got this, y equals 2 to the x. Now, when you see an exponential, let's look at an exponential versus a log, right? I want you to, it's really important to compare the two. Actually, I'm going to scooch over, right? This is what's in your notes. Okay, and I want you to compare these. So every exponential, when it's in a parent function, and this could be anything, it could be 2 to the x, e to the x, 3 to the x, 4 to the x, any number to the x power, its pivot point is right here, and they all look the same. The only thing that's going to change, if you make this number bigger, that curve is going to rise up steeper. But the point I want you to know is 0, 1. Okay, that's the important point. And you remember that. Now we have a log over here. I'll do the log in purple. A log is the inverse. And we're going to study inverses in another couple days. But an inverse means x and y are switched. So if this is 0, 1, that means this is 1, 0 as the point you memorize. And then you're just going to draw a curve through that. And I want you to notice how it grows very slowly. Logs grow very slowly where exponentials grow very quickly. And the way you can remember this, you can kind of cheat. Log is spelled L-O-G. And what numbers do L and O look like? 1, 0. So remember to go through 1, 0. That way, if a log is 1, 0, an exponential, you'll remember, has to be 0, 1 because x and y are switched. Okay? So that's the easiest way to remember that. Now let's look at another graph. What if I gave you this? F of x equals 2x minus 3. That means 3 to the right. Well, we always start counting right here. So I'm going to go 1, 2, 3 to the right. So here's my new point, right? And I just draw a curve like that. It's that easy to move these fellas around. This means down 4, right? That was the point. So your pivot point, we should start right there, but we're going to go down 4. So 1, 2, 3, 4. So there's my new point. And of course, you remember from radii, this line underneath here, 1 unit down, is called the asymptote. So this is going to have an asymptote 1 below it. And we just sketch that in. So these are very quick to sketch. I'm not asking you to plot a lot of points. I just want you to know where they are, okay? And then we'll look at, what about negative 2 to the x? This means flip over x-axis. So if I'm looking at this one, this is where I should start, but I'm going to flip, so I'll be there. Now it should be this little guy, and it's going to be flipped over, so it's going to be that little guy. Okay? And lastly, what about this? Means it is flipped over x and y. This flips it over the y-axis. This flips it over x. So I'm going to draw a little dash line of what it's supposed to be, the parent. Now, if I flip it the other way, it'd be going like this, right? And now I'm going to flip it down, so it would then look like that. Okay, that's just a little on transformations. If I took the logs now, the transformations are going to work exactly the same way. So if I said f of x, and these blank notes are in there, and the key is under, again, this is under day 0, because this really isn't part of the unit, it's prerequisite material. So this goes 3 left because of this, right? So here's where I should start, and I'm going to go 1, 2, 3 to the left. So there I am, and there is going to be an asymptote 1 before, right? So for a log, that's your asymptote. So it never reaches that, and you just go like this. I don't care that you're not plotting any exact points. That's not important to me right now. So what if we did log 2 x minus 5? Now you notice this 5 is not in parentheses, so this is down 5. So I should be starting right there, but I'm going to go down 1, 2, 3, 4, 5, and I'm going to start there. Right? Again, 1 to the side before is going to be your asymptote, and then right here. Okay? And that's just, what about negative log x? So this means it's reflected in the x-axis, so it's upside down. So my log, the one I'm supposed to draw, the parent, look like that. So if I flip that upside down, it's going to look like that, right? Of course, I still have an asymptote there, but this was the parent, and then here's my new one. One last one, and we'll let you go for day 0. So this means to reflect in the y-axis. Your x's are going to change signs, so I should be there. So instead of being there, if this is my mirror, I'm going to be right here. So this is what it would have looked like, but I am making a reflection in the y-axis, so it's going to look like that. Of course, the asymptote is still there. Okay, so practice drawing these. This is just some memory work from parent functions and how to graph those. And again, this is just lesson 0. Great news. There's no homework over this. Just pull your notes out and try to do them again and make sure you know how to do it, okay? Adios until next time.